Welcome to our channel. Today, we're diving into the mind-blowing infinity of the universe. We build structures, we create languages, we invent technologies, but then we look up at the night sky, a vast canvas of twinkling lights, and we're reminded of just how much we don't know. The universe, with its sheer scale and mysteries, has a way of making us feel both incredibly small and infinitely curious all at once. So, let's embark on a journey to the edge of our understanding, to explore 10 mind-blowing facts about the universe's infinity. Imagine a loaf of raisin bread baking in the oven. As the bread expands, the raisins within it move further apart. That's a simplified way to think about the expanding universe, but instead of raisins, we have galaxies. The universe isn't just expanding, it's doing so at an accelerating rate. This suggests that a mysterious force, dubbed dark energy, is at play, pushing everything further apart. This expansion also means that the universe had a beginning, a point in time when everything was condensed into an infinitesimally small point. We call this event the Big Bang. From that initial singularity sprang forth all the matter and energy that make up the universe we observe today. Our sun, a blazing ball of hydrogen and helium, might seem unique, but it's just one star among hundreds of billions in our Milky Way galaxy. And the Milky Way? It's just one galaxy among hundreds of billions more scattered throughout the observable universe. Hundreds of billions of galaxies, each containing hundreds of billions of stars. The sheer number of stars in the universe is staggering, more than all the grains of sand on all the beaches on Earth. By observing a small section of the sky and counting the galaxies within that region, astronomers can estimate the number of galaxies in the entire observable universe. The next time you gaze up at a clear night sky, remember that each point of light represents a sun, perhaps orbited by its own planets. The possibilities are as limitless as the universe itself. This vast sea of stars is a testament to the universe's incredible fecundity. We like to throw around the word infinity, but what does it actually mean? In the context of the universe, it refers to something that's unbounded, without limits. But our ability to observe the universe is limited by the speed of light. Imagine a ship sailing on the ocean. The ship's horizon represents the farthest point it can see. Similarly, our cosmic horizon, the edge of the observable universe, represents the farthest point from which light has had time to reach us since the Big Bang. Because the universe has been expanding, the actual distance to the cosmic horizon is much farther, about 46.5 billion light-years. That means the observable universe is a sphere with a diameter of 93 billion light-years. The observable universe is just a tiny fraction of the entire universe, which might be infinite in size. What wonders lie beyond our cosmic horizon? We can only imagine. The matter we can see, the stars, planets, and galaxies, make up only about 5% of the total mass and energy content of the universe. The rest is shrouded in mystery, composed of two enigmatic entities, dark matter and dark energy. Dark matter doesn't interact with light, making it invisible to our telescopes. We know it exists because of its gravitational influence on visible matter. It's like an invisible hand shaping the structure of galaxies and galaxy clusters. Dark matter makes up about 27% of the universe, and while we can't see it directly, its presence is felt everywhere we look in the cosmos. We are still piecing together the puzzle of dark matter, trying to determine what it's made of and how it came to be. Its existence challenges our understanding of physics and hints at the possibility of new particles and forces beyond the standard model. The universe is ancient, a grand old storyteller with tales that stretch back billions of years. Its story begins with the Big Bang, the event that set the cosmos in motion 13.8 billion years ago. In the first fleeting fractions of a second after the Big Bang, the universe underwent a period of rapid expansion and cooling. As the universe continued to expand and cool, protons and neutrons combined to form the first atomic nuclei, mostly hydrogen and helium. It took about 380,000 years for the universe to cool enough for electrons to bind to these nuclei, forming the first atoms. The faint afterglow of this event, known as the cosmic microwave background radiation, can still be detected today. Over billions of years, gravity pulled together clouds of hydrogen and helium, causing them to collapse and ignite, giving birth to the first stars. The universe, once a cauldron of energy and elementary particles, had transformed into a vast and complex ecosystem of stars, galaxies, and planets. Our universe, vast and ancient as it is, might be just one of many, like a bubble in a cosmic bubble bath. This mind-bending concept, known as the multiverse, arises from theories such as inflation and string theory. Inflation predicts that our universe is just one patch of space-time in a much larger inflationary multiverse. String theory suggests the existence of extra spatial dimensions beyond the three we experience. These extra dimensions could potentially host other universes with different physical laws and constants. Imagine a vast ocean, with each wave representing a different universe, each with its own unique properties and history. The concept of the multiverse is still highly speculative, but it offers a tantalizing glimpse into the potential vastness and strangeness of reality. If the multiverse exists, it raises profound questions about the nature of reality and our place within it. We humans have a natural inclination to seek out centers. The Earth was once thought to be the center of the universe, with the sun, moon, and stars revolving around us. But our cosmic perspective has shifted dramatically over the centuries. We now know that the universe doesn't have a center, at least not in the traditional sense. This mind-bending concept arises from the fact that the universe is expanding equally in all directions, like the surface of an inflating balloon. Imagine you're an ant crawling on the surface of a balloon. As the balloon inflates, every point on the surface moves away from every other point. Similarly, in our universe, every galaxy is moving away from every other galaxy, and there's no single point that can be identified as the center. We are all adrift on this expanding sea of space-time, equal participants in the grand cosmic dance. Black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape, are among the most enigmatic and awe-inspiring objects in the universe. They are formed when massive stars collapse at the end of their lives, their cores crushed under the relentless force of gravity. Black holes are often depicted as cosmic vacuum cleaners, sucking up everything in their path. However, their gravitational pull is no different from that of any other object with the same mass. If our sun were to suddenly collapse into a black hole, Earth's orbit would remain unchanged. What makes black holes so bizarre is their incredibly high density. Imagine squeezing the entire mass of the Earth into a sphere the size of a marble. That's roughly the density of a stellar mass black hole. Supermassive black holes, on the other hand, lurk at the centers of galaxies, including our own Milky Way. These behemoths can have masses millions or even billions of times greater than the Sun. We've explored the universe's contents, its age, and its expansion. But what about its overall shape? Is it flat like a sheet of paper, curved like a sphere, or something else entirely? The shape of the universe is determined by its curvature, which is related to the density of matter and energy within it. There are three main possibilities: a flat universe, a spherical universe, and a saddle-shaped universe. Observations of the cosmic microwave background radiation suggest that the universe is remarkably flat, with a curvature very close to zero. This finding has profound implications for our understanding of the universe's evolution and fate. A flat universe will continue to expand forever, albeit at an ever-decreasing rate. The shape of the universe is a testament to the elegance and simplicity of the laws of physics. The universe, born in a fiery explosion billions of years ago, is not immune to the passage of time. Just like us, it faces an eventual end, though its demise is likely to be far more dramatic than our own. Cosmologists have proposed several scenarios for the universe's ultimate fate, each more mind-boggling than the last. One possibility is the Big Freeze, also known as the heat death. In this scenario, the universe continues to expand indefinitely, but as it does so, the stars will eventually burn out, galaxies will drift apart, and the universe will become a cold, dark, and desolate place. Another possibility is the Big Rip. This scenario posits that the expansion of the universe will continue to accelerate, eventually becoming so rapid that it overcomes the gravitational forces holding galaxies, stars, and even atoms together. Finally, there's the Big Crunch, a scenario in which the expansion of the universe eventually reverses, and gravity pulls everything back together in a cataclysmic collapse. The fate of the universe is a stark reminder of the transient nature of existence. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content about the universe. See you next time. As we've journeyed through these 10 mind-blowing facts about the universe's infinity, we've encountered concepts that challenge our imagination and redefine our place in the cosmos. From the accelerating expansion of space to the potential existence of a multiverse, the universe continues to surprise and amaze us. The more we learn, the more we realize how much more there is to discover. So keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the universe.